we are going to take a look at how to graph the graph of y equal to x squared and different transformations we can apply to this graph. First, if you wanted to graph y equal to x squared, and let's say you had this table which you created, you would get the point -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So this graph is in red. It's the graph of my main function. Let's now say I wanted to graph the graph of y equal to x squared plus 1. Now I'm going to show you what it's going to look like with the points -2, 5, -1, 2, and so on. If I were to plot the blue points, -2, 5, -1, 2, and so on. So here it is, -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. Notice that those blue points, if you were to join them, you would get the blue parabola, which is going to take a look at the folder of the equation y equal to x squared plus 1. Inside this folder, you will find many documents, y equal to x squared, and I will refer to those documents. As you can see, it's a dotted parabola. It's just a reference to compare my blue graph to. Now notice one thing. On the dotted graph of y equal to x squared, which is my main graph, you have the point 0, 0 over here. Now this point 0, 0 was moved or shifted up to the point 0, 1. Notice that the y values over here for y equal to x squared, notice that the y values over here in blue are basically 1 unit more than the y values in red. Therefore, all the blue points are 1 unit higher than the red points. It's like if we picked up the red parabola and we shifted it 1 unit up to get to the blue parabola. So when you have y equal to x squared and you get the graph of y equal to x squared plus 1, basically it is going to pick up your main graph y equal to x squared and move it 1 unit up. If you wanted to use the calculator, you would type y is equal to x quantity squared. That will be your reference graph. And then your other graph will be x quantity squared, and then you would add a 1 to that. Now let me do one thing. Let me make the graph that we care about, y equal to x squared plus 1, bold by just altering over here the pattern of graphing. And the one for y equal to x squared, let's make that dotted by pressing enter a few times, and we're going to have now a dotted pattern. So remember, the main graph y equal to x squared, just like on my picture here, will be dotted, and y equal to x squared plus 1 will be a solid bold graph. What we can do is look for the zoom. If you press over here the zoom key, it says zoom decimal item 4. If you did this, you notice that clearly over here the bold graph of y equal to x squared plus 1 is basically obtained by the dotted graph called about 1 unit higher. Inside this folder, and if you wanted to check points, you could just say second trace, which is a calculate menu, and press value, and you can type 0. If you press enter, it tells you that y is 0 when x is 0 for the first graph of y1 equal to x squared. If you wanted to see what is the y value when x is 0 on the second graph, you just press your up arrow and you will jump to the other graph. And that is when x equal to 0, y equal to 1. And what you could do as well, if you want other values, you just press whatever you want. We're going to take a look at the folder called 1, press enter, and you can basically check that on the second graph y is 2. If you jump down on the first graph y equal to x squared, y is 1. Now if you did pick a value which is too big compared to the x's that are allowed on the screen, let's say x is 6, you would get an error message just because you picked an x which you cannot view in the screen. So check that out. Now because I have an error message, let me just press over here 1, which is to quit. If I did a second window over here to do a table set, what you have. Let's say you wanted to start your table at negative, doesn't matter. Let's say -3 or whatever. You could have started it at -2 as well. If you were to now go ahead and do a second graph or a table, then you can see that when x is -3, let's just take the value we know. We can always arrow down and check out what we want. When x is -2, for y1, which is y equal to x squared, you would get y is 4. And for y2, which is my blue graph over here, when x equal to -2, y was 5 indeed. So you see both tables over here for y1 and y2. And you can scroll up and down and check out different things for those two tables at the same time. Show you one more thing. When x over here, let me just arrow up to highlight. When x is 0 over here, y1, which is y equal to x squared. Over here, y2 is 1. For the second graph, when x is 0, y is 1 over here. So you can use your calculator to your advantage. Remember now that when we have y equal to x squared, if we just add a 1 and we say y equal to x squared plus 1, what it's going to do is going to pick up our main graph and shift it vertically 1 unit up. So now let's take a look at the graph of y equal to x squared and y equal to x squared minus 1. If you notice, I have my usual parabola with the key points in dotted over here pattern. We have the usual parabola in dotted pattern right here, y equal to x squared. Now if you wanted to graph y equal to x squared minus 1, you would have to plot the point -2, 3, -1, 0, and so on. So you have -2, 3 over here, -1, 0, 0, -1, 1, 0, and 2, 3. Notice that if you wanted to go from the reference graph, the main graph y equal to x squared, to the one of y equal to x squared minus 1, you would have to move every point 1 unit down. Okay? Now let's take a look at the calculator with this. Let me go to y equal to. You can always alter things a bit on the calculator. Let's put a minus sign now. Let's do the table over here. And you can start it at any value because you can always scroll up or down. It doesn't matter. So let's go to the table. And let me just kind of scroll down a bit. Just so that I start on my calculator at the same place for my x's. So when x is -2, y1, which is my main graph of y equal to x squared, y is 4, and y2, which is the y value in blue here for x squared minus 1, for that same x being -2, y is 3. So you do see that we have the same entries, on the calculator as in the red table. It shows up in the first column for y1, and for y2 it's what you had in the blue column over here for the y values. Now let's graph those two functions. Remember again, y equal to x squared is the dotted pattern, and y equal to x squared minus 1 is the bold pattern. Just press graph and you have y equal to x squared, and then in bold y equal to x squared minus 1. Again, if you wanted to check out one point, maybe do a second. I just did a second trace, which is a calculate feature. Press x equal to 0. Right now you are on the equation y equal to x squared on that graph. If you press the down arrow, you fall down on the graph of y equal to x squared minus 1 with entry 0, -1. So you indeed went 1 unit down from your main graph of y equal to x squared, and that for every point. Okay, if you were now going to take a look at the graph of y equal to x squared and y equal to x plus 1 quantity squared, again you would get your dotted graph of y equal to x squared as your main or reference graph, and then for the blue points you would get -2, 1, then -1, 0, 0, 1, 1, 4, and 2, 9. If you were to join those blue points, you do get a parabola. How does this parabola compares to the one of y equal to x squared? Notice that y equal to x squared passes through 0, 0, but now that point, which we call the vertex, got moved to the point -1, 0. So it's like if I picked up that point and every other point and moved them 1 unit to the left. So we basically move those points 1 unit to the left, all of those, okay? And that's how you go from the red graph to the blue one. Now with the calculator, let's go to y equal to, and let me do one thing over here. Let me just go ahead and deactivate this function by pressing enter and just type for you. Oh, by the way, let me just put a little plus sign here just to show you the first one we ever did and to show you now the one we would like to type. Notice it says y equal, and in parentheses you have x plus 1 and the whole thing is squared. So you need a parenthesis and then you have an x plus a 1 and then you need to square that quantity. Notice how different it is from the first graph we ever basically constructed in blue. We had x quantity squared plus 1. The plus 1 was outside of the x being squared over here. Now we have x plus 1 together, that sum being squared. So that's a different thing than what we had originally. Let me just deactivate the graph y2 because we're done with it. And let me just basically graph y equal to x squared and x plus 1 quantity squared. Now, let me do a table. And let's just go and just say second table. Notice when x is -2, y is 4 for y equal to x squared. That's y1. And then for the blue y is 1, and that's what I call y3. So basically we do get the same information right here as what we have in those tables. So we have y equal to x squared and then the graph of y3. Let me make that bold. And let's take a look at the graph. So we have y equal to x squared, and here's a bold graph of y equal to x plus 1 quantity squared. It's exactly what we have right here. Notice again the vertex went from 0, 0 to -1, 0. So now let's take a look at the graph of y equal to x squared and y equal to x minus 1 squared. You do have the point -2, 9, -1, 4. You have 0, 1, 1, 0, 2, 1. Okay, so if you were to join those points, you do get this blue parabola. Notice that the vertex, which used to be at 0, 0 for the graph y equal to x squared, is now at the point 1, 0. So it's like if we picked up that point and moved it 1 to the right, and we did that for every point over here. If you had the calculator and you wanted to type that in, you would have to go with y is equal to, remember the second graph we did was x quantity squared minus 1. We're not doing that anymore. I'm just typing it just so you can see the difference. Now what I want to do will be entered in y3, and it will be x minus 1, and the whole thing will be squared. Okay, so x minus 1 quantity squared. Let's do a table and check that it is indeed the same thing. It's giving us the same value, 4 for the red table for y, 9 for the blue table for y. So you do have the correct entries here. Let's do graph. Okay, I can see y equal to x squared passing through 0, 0, and now the shifted graph y equal to x minus 1 quantity squared. So now for y equal to x squared and y equal to the opposite of x squared, notice you have the red graph of y equal to x squared dotted, polar opening upward. When you have y equal to opposite of x squared and you plot the points -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4, notice that basically your green graph is like a mirror image of the red graph. And we do say that to go from y equal to x squared to y equal to opposite of x squared, that green graph, we have a reflection like a mirror image in the x-axis. The x-axis acts like a mirror over here. So now if we were to use the calculator, let me just go ahead and clear this function out and clear this one out. and just type over here a negative sign next to the enter key and press X. A second window or table set. Let's check out that table. And notice that the y values for y equal to x squared are positive 4, 1, 0, 1, and 4. But when you look at the y values over here for y2 or y equal to opposite of x squared, they are basically the opposite values as the ones we had in red. So that's why when we were here for y is 4 when x is negative 2 on the red graph, we do have a y which is negative 4 on the green graph, and this for every y value. So that's why you have a mirror image. So if you were to graph those functions, make that graph bold. And if I were to go ahead and graph, I will get a parabola opening up and a parabola opening down. And the bold parabola is a mirror image of the parabola opening up of y equal to x squared. So now as a recap, let me just show you again how we type those. We had y equal to x squared. The first one we typed was x quantity squared plus 1. That was a vertical shift 1 unit of our main parabola. Then we had x quantity squared minus 1. That was a vertical shift 1 unit down from the graph of y equal to x squared. Then we had the horizontal shifts, and we obtained those by putting a parenthesis, and inside, let's say x plus 1 quantity squared. When you see plus 1, you kind of want to go right because you're thinking 0. You know, if you wanted to go from 0 to 1, you would go right, but it's misleading. When you have a x plus 1, it's a horizontal shift 1 unit to the left. And then if you have over here x minus 1 quantity squared, that's a horizontal shift 1 unit to the right. And the last one we did is opposite of x squared. When you have this, it's a reflection. When you have a negative like this in front of your main function, it's a reflection in the x-axis. Okay? So those things we have learned on y equal to x squared apply to any main function you can think of.